All right, 5.4, we're going to skip over 5.3 and we'll get into graphing later. We did 5.1, we did 5.2, we're going to go 5.4 and solve radical equations and inequalities, and then we'll come back to the graphing side. Okay, you're going to have a small quiz on, I believe I've got it on Friday, over 5.1, 5.2, and 5.4. Okay. So whenever we solve radical equations and inequalities, okay, we'll spend 2 days in this, and then we'll go back to 5.3 and kind of go from there. You'll have a little bit of time to review, or I'll give you a review over that, over those 3 sections, and then kind of have like a little mini quiz on, I believe I've got it on Friday. I have to check the calendar. So whenever we solve radical equations, okay, you're really going to have 2 types. You're going to have one type where you're only going to have one radical, and then you're going to have another one where you're going to have 2 radicals. Okay? So whenever you have one radical, the biggest thing is you want to isolate isolate the radical to one side of the equation if necessary. So that means if you have everything else, so like on example A, where I have 2 times the square root of x plus 1 equal to 4. Okay? I want to get the square root by itself. So how am I going to isolate the radical, or how am I going to get rid of this 2 that I have on the left side? What is the 2 doing to everything that's inside the square root of x plus 1? It's multiplying. So what do I need to isolate it? I need to divide. So I'm going to divide both sides by 2. So the 2's go away. So I have the square root of x plus 1 equal to 2. Now, it's the opposite of what I did whenever I had an x squared before. Before, whenever we solved quadratics, we took the square root of x squared. So now if we have a square root, how am I going to get rid of the square root? What do I need to do to both sides? Square it, right? So I need to take both sides, and I need to square each side of my equation. So what am I left with on the left side? X plus 1 and 4, right? I need to isolate x. I need to get x by itself. So step 2 was raise each side of the equation to the same exponent to eliminate the radical. Then solve the resulting equation using techniques you've learned. So how am I going to isolate x? What do I need to do to get x by itself? Subtract 1. Now, whenever I do this, I have to make sure that whatever it gives me as far as my answer, if I get x equal to 3, I've got to make sure whenever I plug it back into the very beginning that it doesn't give me a negative if it's an even root. So if I plug 3 back in there, is 3 plus 1 still positive? Yeah. Okay. It doesn't matter so much on B as it does on A. Okay, so because it has an even root, okay, if it's to the second root or a square root like this one, if it's to the 4th root, the 6th root, whatever, okay, that number inside, whenever it goes back in, okay, it needs to make sure that it's positive. If it's negative, then that's going to be a case where it's not going to have that answer. Okay, you may have some of these that have 2 answers. We'll get to that in a little bit. So then again, so if on B I have the cube root of 2x minus 9 minus 1 equal to 2. How am I going to get the cube root? How am I going to get the cube root by itself? What do I need to move first? Add the 1. So I have the cube root of 2x minus 9 equal to 3. Now, what do I need to do to both sides? This is basically step 2. What power do I need to take both sides to? The third. So take that to the third, take that to the third. So I'm looking at 2x minus 9 on the left and 27 on the right. Now just solve the equation. So I need to get x by itself. So I'm going to add 9 to both sides. I'm going to have 2x equal to 36. Divide both sides by 2 and get x equal to 18. So here it says in a hurricane, it says the mean sustained wind velocity, V, in meters per second can be modeled by V of P is equal to 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. Okay, so then it says estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So basically, whenever they measure a hurricane and the wind velocity, they go to the center of the eye of the hurricane and check the air pressure to see what the average wind velocity is, because it's going to be different in different pockets of a hurricane. Okay, so it's basically their best educated guess, or the best way that they can do it is to go to the center where the hurricane's not happening and take the air pressure there. Okay, and go from there to find what the actual mean, like whenever you see it on the news, whenever they say that the speed of the hurricane or the wind mile per hour of the hurricane, as far as to give it its categories, is 75 degrees, 130, 140, whatever. Okay. So if we go with the wind velocity being 54.5 equal to 6.3 times the square root of 1013 minus P. So what's the first thing that I have to do? How am I going to get the square root by itself? Divide by the 6.3, right? So I'm going to have 54.5 divided by 6.3. Now, in this case, you're going to need to estimate, so I'm going to have to, if you want as close to it as possible, I would, as you go in your calculator, I would just leave your numbers in there. Okay? If you're going to write it step by step, then you're going to need to round as you go, because whenever I take 54.5 divided by 6.3, I'm going to get 8.6507, so on and so forth. Okay, it's going to go all the way out. So I would leave that number as you go. And then, so like if you're going to write it as you go, that's fine, but I wouldn't take those numbers out of your calculator. Does that make sense? So even though you're going to have about 8.6508, okay, equal to the square root of 1013 minus P, I would leave the number that you have in your calculator, and then I would just hit the squared button, because it should keep your answer as you go. And then again, so now I have 74, or about, like if I would actually write this as I go, it's about 74.8362. Okay, about. And then whenever I square it, whenever I squared both sides to get rid of my radical, and then I have 1013 minus P. I'm going to subtract the 1013, okay, and then so I'm going to have about negative 938.1638 is equal to negative P. So the pressure, if I round this, is going to be about 938.16. Okay. Now that's millibars per second. Now, last type for today is going to be when you don't necessarily have, you still have one single square root, or you may have one on each side, but you still have a variable on the other side. Okay? This is one of those that more often than not, especially if you only have one square root or one radical, and then you have a linear equation on the other side, like the x plus 1, you're going to get two answers. Okay? Both answers could work, none of the answers could work, or one of the answers could work. Okay? That's where you've got to plug it back into that original and see if you get a positive number, especially if it's a square root or a fourth root where the negatives matter. That could give you a wrong answer, because you still have to get rid of the radical. Okay, you still have to get rid of the radical here, so I still have to take each side and square it. So the right side is completely fine because the square root and the square just cancel each other out, and I'm left with 7x plus 15. It's the left side where students get, if there's going to be a mistake that gets made, that's where it's going to get made. Now, remember, all x squared is just, or x plus 1 squared, excuse me, is just x plus 1 times x plus 1. So then I'm going to have x squared plus 2x plus 1. Now again, I need to get everything over to one side. If you have a quadratic, then I need to get everything over to the one side, and I'm going to have to factor it most likely. Okay? A lot of these, if any, or really most likely none of these, will be you having to use like quadratic formula. Okay? They're going to be nice, neat numbers for you to use. So if I move everything over to the other side, if I subtract the 7x and I subtract the 15, I'm going to have x squared minus 5x minus 14 equal to 0. So then I need two numbers that multiply together to give me negative 14 and combine to give me negative 5. So what are those? Multiply to give me negative 14, combine to give me negative 5. Negative 7 and a positive 2. So then my two answers that I have are going to be x equal to 7 and x equal to negative 2. I need to check to make sure that everything's going to be okay whenever I plug those numbers back in. If I plug 7 back in, I get 7 plus 1, that's 8. Everything's good, right? If I have 7 times 7 plus 15, 49 plus 15 is 64. Square root of 64 is 8. Everything's good with the 7. So everything's good here. What about the negative 2? It's okay to get a negative answer. Okay, I just can't get a negative inside the radical. So now, what's negative 2 plus 1? If I plug the negative 2 right back in here, what's negative 2 plus 1? Negative 1. Is the square root of, this is just going to be negative 14 plus 15. Is the square root of 1 negative 1? No. So does negative 2 work in this case? No. All right? There are going to be times that you're going to have answers that it's going to be okay. All right? But in this case, this is not one of those times. Negative 2 will not work because the square root of a number, okay, is not going to produce a negative. Now, on one like 6, 6 is probably one of the easier types, because what am I going to do to both sides? Square both sides. So what's really going to happen here? If I square both sides, everything drops off, and I'm just dealing with 2x plus 5 equal to x plus 7. Those are the ones that I like. Those are the ones that I want to happen. So I'm going to have x equal to 2. Go back in. 4 plus 5 is 9. 2 plus 7 is also 9.